Hello everyone, this is Siddharth, and in this video we will be solving another question from the list that I have shared in the starting of this playlist. So if you don't know what we are doing in this playlist, we are solving all those questions which are related to each other so that we can able to build patterns and able to retain the standard processes and the methods so that we can able to solve other question in the contest as well as in the interview intuitively. So let's start solving this question as well. So, and let me tell you one thing more that currently we are solving all those questions which are comes under the sliding window category. And before this category, we have already solved too many questions which are related to two pointer. For and also in the two pointer also we have solved two kind of question. One will be the same, the speed of the both of the pointer are same, uh, and the another one will be one is slow and one is fast. Okay, so here we are like solving all those question which are comes under sliding window. So in this question what we have to do, we have given an we have given an array and which is representing the position of a stone on the x-axis. So let me draw it so that you can visualize it. So suppose this is our x-axis, this is y-axis. Let me fix it. Okay, or let me draw it again. Sorry for this. Okay, so this is better. So now suppose this is our first stone which is point, or just take this array as an example, that is 6, 5, 4, 3 and 10. So 3, 4, 5, 6 and then 10. Now what we have to do, and this like number line is already suggesting us that we can short this array, so that can really be helping us to solve this problem. So now what we have to do, we have to uh, move our stone so that all the stone will become consecutive in the end. And also we cannot move the end pointer, or we can say we cannot move this end point stone because this is already at the end point position. Now we will not able to move it to the start, because start is also like, if we will move this 10th position stone to second position stone, then it will not like do the job for us, because in that case also this 2 is the end point, because the smallest and the largest value are the endpoint stone, so we cannot move them. So that's why we cannot move this. So what we can do, we can move this 10th position stone. Let me draw it. 10th position stone to the 9, and then 9 to 8, and then 8 to 7. So what this will ensure, that we are not like violating the condition that we have given in the question, and also we are finding the moves to make all the stone consecutive. And now what additionally we have to do here, we have to find the minimum and the maximum number of moves. So let me fix this first so that you can able to see it properly. Now we have to find the minimum number and the maximum number of moves uh, to like end this game. So the maximum number of move will going to be uh, the minimum number of moves will going to be, either we can like let me show you here. So we can move, the minimum number of moves is we can move at 3 to 8, then 10 to 7. So how they are like explaining it, 3 to 8, and then like 8 is completed. Now this 4, 5, 6 and then 10 to 7. So let me see if they are doing the same. 3 to 8, then 10 to 7. Yeah. So what it does, now our position of the stone will look like 4, then 5, then 6, and then 7, and then 10. Oh, sorry. This 3 we have moved to 8 and 10 to 7, or we can do the vice versa, 3 to 8 and 10 to 7. And let me do this, erase this. Now this will look like we have moved 3 to 8. So let me fix 3 to 8 we have moved, and then 10, then we have moved 10 to 7. So 3 we have moved from here to here, and then 10 we have moved, uh, or 10 we can move to 7, and 3 to 8. Why? Because we don't have to like move the end point, stone to end point, otherwise we will be violating the condition. So this is the right approach to solve this. So this our stone position will now look like 4, 5, 6, 7, 8. So this is the minimum number of moves that we have done, and the maximum number they are already, they have told us that 3 7, 3 to 7 we can move, 3 to 7 we can move, and then uh, 3 to 7, and then 4 to 8. Or let me tell you, so what we can do for finding the maximum moves, what we can do, we can move to the that position stone where the difference is higher. So that what it does, it will help us to find the more moves. So this 10 is here. Now what we can do, we can move this 3 to 9, and then 4 to 8, and then, or what we can do, 4 to 8, yeah, we can do 4 to 8, then 5 to 7, 5 to 7, and 6 is already here. So the total number of moves, the 3 to 7, 4 to 8, 5 to 9. So this will going to be 3 moves that we have done. So this is another approach to like end this game. So now what we can do to like solve this question. So I have already told you that we will be using sliding window. So sliding window we can use for finding the minimum moves. Why is it so? Because after finding total number of consecutive, like this is the standard process, you can understand it as well. We will be like moving, taking two pointer, and we will be increasing the window size as we are encountering the element, uh, as we are encountering the element, and then we will be moving our window until and unless we have encountered that element whose difference with the left pointer is greater than the value of n. Because if they are consecutive, then their difference is also equals to n. As soon as we have identified the outlier, then the difference will become greater than n. Now this what it does, it will calculate the longest consecutive window. So after calculating this, now let me tell you, so 3, 4, 5 and 6, this is the longest consecutive window, and this is 10. Now what we can do, we can, by doing this, we are finding that the longest consecutive window is 4, and the longest consecutive window is 4, and the length of the array is 5. Now what we can do, we just have to calculate the space. So that will going to be, length of the window is 5 and the space is 4. Length of the window is 5, length of the window is 4, and the length of the array is 5. Now what we can do, we can do like this, 5 minus 4 plus 1. So what it does, it will calculate the space that is left, the space that is left, so that we can fit this element into the left slot. So this will uh, this will this will handle the total number of moves that we have to do, or we can say the minimum number of moves. But in this case, this is an edge case, and we have to handle this because in this case we don't have, like, we cannot move this 10 to 2 because there is only one slot left. So we cannot move this 10 to 2 or 7 because both of the case the condition will violate. So in this case what we can do, we can put an edge case, and we can, instead of like returning 1, we can return 2. Sorry, let me fix. Instead of returning 1, we can return 2. Because and what is like, what does it what is the significance of this, that we can move 10 to 8, then 8 to 7. So this we are doing, not like we are showing or like telling, but we are like unconsciously, oh sorry, we can think this as like we are moving 10 to 8, then 8 to 7, not we are moving it directly. So in this case we have to return 2. And now how we can handle this case, that after we will be like moving into this array using the sliding window, as soon as we have encountered the element, as soon as we have encountered that element whose difference with the left pointer is equals to the n minus 1, or we can say length minus 1, and also the length of the window is equals to n minus 1. So this will handle the case, and in this case we have to return the, or we have to store the minimum value as 2, as compare as, otherwise what we have to do, otherwise we have to uh, store in the minimum value, we have to store the minimum value, what we have to store, we have to store n minus the length of the window, longest window, subsequence window. So what does this step does, it will calculate all the left slot in the position of the stones. And how we can say that, uh, s- let's take this as an example, that is 4, 7 and 9. So this will going to be 4, 7 and 9. And now we will move a left pointer to here, and then here, and then here. And in this case if you like try to calculate, then this will going to be longest common subsequence will going to be the length of the window will going to be the will 1, and the length of the array is 2, n is 3, sorry. So n minus longest one, 3 minus 1 is equals to 2. That will going to be a 1. But also we have to like calculate the window sizes, right minus left plus 1. So this will going to be 2. So what we will be doing, we will be doing is 3 minus 2 is equals to 1. So this will going to be the minimum number of moves. So now after doing this, we can able to find the minimum number of moves. But for maximum number of moves, what we have to do, we have to calculate the minimum and the maximum number of moves. So oh sorry, maximum number of moves from the both of the side, that is left end and the right end. Let me tell you, that is, let's take this at stone position, that is 3, 4, then 5, then 6, and then 7. 3, 4, 5, 6, oh sorry, this is 10. So now what we can do, we can calculate the left slot between this and this, and then 4 to 10. Why we are doing this? Because in the edge case, what can be the situation that one side there is more difference as compared to other side. Then in that case we have to take care of the left slot from both of the side, so that we can able to get maximum number of moves. Now this 6 minus 3, the spot between these two number will going to be 6 minus 3, and also these two stone have already occupied the position, so we cannot use that. So 3 minus 2 is equals to, this will going to be uh, 6 minus 3, and this will going to be 4, because sorry, this will going to be 6 minus 3 plus 2. We can like do like this, that we can add one more element here, so that this will come as 0, or we can say n minus 2, that is 5. Length of the array is 5, and we will be subtracting 2 from it. So uh, because we have used these two stones already there, so we cannot use those position. So 5 minus 2 will going to be 3. So here we have used this 3. 6 minus 3 minus 2, this will going to be 1. And so 6 minus 3 minus 2 will going to be, the length of the array is 5 and the element that we have used is 2, so this will going to be 3. Sorry for this. So this will going to be 6 minus 6 is equals to 0. So total number of moves that we can do, so that we can uh, the number of slots that are left between this is 0, as you can see as well. The position is already filled by these 4 stone as they are consecutive. Now we will try to calculate between this 4 and 10. Then it will came out to be 10 minus 4 minus 3, that is 3. And if you will try to calculate, there are exactly 3 slot left after this 6. So we can move 10 to 9, then 9 to 8, and then 8 to 7. So what it does, it this approach will correctly able to identify that there are 3 position. We have to move this stone to get the maximum number of moves. So this is the approach that guys we will be solving. If like I will try to summarize it, for solving this question we have to find the minimum number of moves and then maximum number of moves. Minimum number of moves we can find, a minimum number of moves we can find using this sliding window approach. So for this, I have already told you how we can do this. We can make 2 pointers, then we will increment our window. If we are able to get the difference of the left and right pointer greater than n, then we will be like moving to the left side. Otherwise we will be uh, updating our minimum moves, and this will calculate the minimum number of moves to move the stone, so that we can end the game. So, and in the maximum and for the maximum part, what we are doing, we are calculating all those positions. Maximum, for maximum one, we are calculating the distance for this 3, then 3 to 10, then 6 to 10, and able to like calculate the maximum from the left end and the right end, and then we can store that into the new result array. So this is the solution that we can use to solve this. Now let's code it out as well. Okay, so first what we can do, we can sort our array. So arrays dot sort, then we will be passing this nums, and then let's calculate the length of the array as well. So and int n is equals to nums dot length. Now we can calculate the maximum number of moves, that will going to be int maximum values. Int maximum value, we can take it as this, and that will going to be math dot maximum of this. Let me take it from here. That will going to be 3 4 5 6 7, then 3 and 6. So let me take it using the notation. So stones of n minus 1 minus stone of, this will going to be this 3 and 6, that will going to be stone of if we will like taking n minus 1, then we have to take the second element, so that will going to be stone of 1, and then we have to subtract the stone that we have, the position that we have already used, that will going to be n minus 2. Now another will going to be, let's copy paste and then let's change that. So this will going to be stone of n minus 1 stone of n minus 2 here we can take, and here we can take stone of 0. So this will going to be 3 and 6 and then 4 and 10, so that we can able to get the maximum moves. And then now what we have to do, and also let's make an result array. So result is equals to new int, and the length of this will going to be 2. And now after this, what we have to do, we have to find the minimum number of moves. And for finding the minimum number of moves, we have to use the sliding window approach. So for that, let's define the minimum values. So minimum value is equals to integer dot dot max value, as we have to take minimum one. So we can do like this to take the maximum value of the integer. And now what we have to do, we have to make two pointer, int left is equals to 0 and int right, or we can directly define it inside the for loop. So for int right is equals to 0, this right should be less than the value of n, then right plus plus. And after doing this, what we have to do, we have to calculate the minimum value for this given array. So let me tell you, that is 3 4 5 6 and 10. And now we have to start expanding our window from here until and unless. So for that, we can define a condition while this uh, stone of right minus stones of left is greater than the n value. If this is the case, then we have to increment our left pointer, left plus plus, and otherwise we have to update our minimum value. So minimum value will going to be math dot minimum of this minimum value and this minimum value, and what is the other one, that will going to be n minus the longest window length. So for that, we have to calculate it as well. So int longest subsequence window length window, so this will going to be right minus left. So this will calculate the length of the window that we have just calculated. So right minus left, and then we are taking minimum of minimum value and n minus this longest. Let's copy paste instead of typing it again. So this bracket should be here. So n minus longest sub window, and also we have to handle the edge condition as well. If the longest, we have copied it already, so longest sub window, if that is become equals to n minus 1, and another condition will going to be the stone of right and stone of left should also will become equals to n minus 1. If this is the case, then we have hit the base case, which is in this case. Then we have to take the minimum value as 2 is equals to, let's copy paste it here instead of typing. So minimum value will become math dot minimum of minimum value and 2 to handle this case. And then we are updating our minimum value from here for else part. And now, or take this as, we can directly take in the else case as well. Okay, so this will calculate the minimum value for the other case as well. And now what we have to do, we have to return we have to return this result array. And for that, let's store the value of that as well. So here we have calculated the max value, then we can store result of 0 as max value. max value, and then after calculating the minimum value we can store that as well. So result of 1 will going to be minimum value that we have calculated. Okay, so first we have calculated the maximum value, and then for minimum value we are using the sliding window approach. So while stone right minus stone of left is greater than n, then we are moving left pointer. Otherwise right, or we are already moving inside this for loop. And then we are calculating the longest sub window length, that will going to be right minus left plus 1. Sorry. So after calculating this window length, then we are checking if this longest sub window will become equals to n minus 1, and the stone of right minus stone of left also become n minus 1. Then we are updating our main value to this so that we can handle this edge case. And otherwise we will be like using the similar approach for each and every case. Now we can like try to run this and check, or sorry, this should be stones, and here also we have to update it stones. Okay, now we can try to run this. Okay, stones, and here also we have to do stones. Let me check if I have done the typo. Okay, here it is fine. Now we can try to run this. So there is an issue, let me check. Okay guys, so the issue is uh, this should be left plus 1, and this should be left plus 1. We have done it by mistake. So let me tell you why we are like doing this plus 1 uh, instead of like just calculating this stone minus left. So if you have like done sliding window approach, so let me tell you. So in this 3 4 5 6 7, 3 4 5 6 and 7, sorry 10, we will start from 3 and we will check if nums of right minus left plus 1 is greater than n, which is not in this case because 3 minus 3 is 0. So we will do increase the right value, then here again, and then this, as soon as this right will become 3, so in the next iteration what we are checking if that is become greater than n. Sorry, here, as we have updated this plus value here also and here. So right minus left plus 1, that is will going to be, when we will reach here, that will going to be 6 minus 3 plus 1, that is 4. So it is equals to 5 minus 1, that is 4. So if this is the case, then we have reached that condition where there is only one gap, two gap in the end. So that's why we have like used this plus 1. And here also we have to move our left pointer until unless we are reaching one less than the uh, one less than the difference, because here also 3 will become sorry, this left will right will become here, then here, and then here, and then here. So this nums of right minus left, that is 10 minus 3 plus 1, should be greater than n value, which is also in this case which is already greater than 1 without adding 1. That is going to be 10 minus 3 plus 1 will going to be 7 plus 1 is 8. In some case it can be like uh, less than 1, or sorry, less than the value of n, that's why we are adding 1. So now we can try to run this and check, and now we can submit it as well. Okay, so we have successfully solved this question. See you in the next video. Bye.